Hello, and welcome to this lesson on solving linear equations, or solving systems of linear equations. So we're starting a new unit that's all about systems of equations. That's where we're solving multiple equations at the same time. Essentially, we're trying to figure out where lines intersect. It's really what it really comes down to. The essential question says, how do I solve systems of linear equations by graphing? So this first lesson is all about graphing. So this is going to use a lot of the skills we've learned over the previous bunches of units on slopes and intercepts and slope-intercept form and equations of lines and graphing and all that good stuff. Did you know graphing linear systems helps you see where two things meet when they are in the same place? So let's say, for example, like you're running away from a charging bull. You can run about 700 feet per minute. That's about the average speed a human can run. The bull runs about 1,400 feet per minute. That's twice as fast as you. Now, if you get a 3-minute head start, so when would the bull catch up and meet you? Air quotes, meet you. Well, we could graph the system of equations and we could figure out the bull would meet you. So you right about here, 6 minutes after you started. And they'd meet you at a distance of 4,200 feet. So just shy of a mile is where the bull would meet you. So that's fairly interesting to know. I mean, and that's really, this little bit of information we can turn into an equation like we have here, and we graph it, and we can find where they would meet. So what is a linear system? Well, a system of linear equations consists of two or more equations with the same variables. So like here, this would be a system of equations. This equation has an x and a y. This second equation has an x and a y. I could solve this system of equations using a bunch of different methods. The method we're going to learn about in this video is by graphing. And graphing is not always the best way. In fact, a lot of times graphing's not the best way. But it's a way that sometimes it is the best, and it's the quickest, and it's the easiest. So that's why we learn multiple methods, so you can make an informed decision on which way you would like to do it. What we're looking for when we're finding a solution, the answer to a system of linear equations, it's an ordered pair. It's a point, it's a dot, it's the x and y coordinates that satisfies each equation. It's one pair, one xy, that is true for all equations. And that's always going to happen where your lines intersect. So in this first problem, I will tell you right now, right away, beginning of the problem, that point is the solution to the system of equations. That's not good enough for an answer, though. So we would want to say that that point is the point, 3, 2. That is a much better answer. Now we have at least the x and the y value that satisfy both these equations. And the way we can check our answer, which is a good, useful skill, especially in multiple choice questions, because let's say there's no graph here, and I gave you this system of equations and multiple choice A, B, C, D, and I said which of these points is a solution to the system. All you'd have to do is plug in the points for x and y and see if it makes the equations true. So for example, I'm going to plug in my x value for x, my y value for y in both of the equations below, and I'm going to show you that this one point makes both these equations true. So 3 times the x value was 3, minus 2 times the y value was 2. That was from here. I'm plugging in 3 for the x, I'm plugging in 2 for the y, equals 5. 3 times 3 is 9, 2 times 2 is 4, equals 5, and yes, 9 minus 4 does equal 5. That math checks out. So I just showed that this point is a solution to this line, meaning this point is on this line. I'm now going to show and prove that this point is on this line because, well, when I plug x in for x and y for y, the math should work out. So I'm plugging in 3 for x, 2 for y, 3 plus 4 equals 7, and yes, that math checks out. So this 1 point is a solution to this system of equations, because it is the 1 point, is the only xy ordered pair that will work in both equations, because it's the only point that's on both lines, just right there. If I plugged in another point, say this one here, that is the point 1, 2, 3, 4, 5, 1. If I plugged in 5, 1, it would make this equation work. I'm going to change color and show this. So 5 plus 2 times 1 equals 7. 5 plus 2 equals 7. 7 equals 7. It works because this point is on this line. It makes this equation true. But this point, this 5, 1, will not work in this equation because this point here is not on the other line. Okay, I'm over explaining this to make sure you really understand what we're actually doing. We're trying to find a point that is on both lines at the same time, where the two lines are intersecting. That's really what this comes down to. Okay, letter B. Find the solution to the system of equations, check your answer. So right now, can you find the solution to the system of equations? It's right there. It's where the two lines intersect. It is the point 1, -3. That is the x value and that is the y value that makes this system true. Now, we're going to check our answer. So I'm going to take, and I'm going to plug in my x value for x, 1. My y value for y, -3. So yes, I'm going to have a minus and a -3 equals 4, and I do the math. 1 minus a negative turns into plus. 1 plus 3 is 4. 4 does equal 4. Check. The math works out. When I plug it into the other equation, 4 times my x value plus my y value equals 1. 4 plus -3 is 1, and that math also works. So I found the solution. The answer to this system of equations is this point. And then I went ahead and I checked my answer by plugging in the x for the x and the y for the y in both equations to show that both equations work with this 1 point. Here's one for you to do. I would like you to do the whole thing. I would like you to find the solution. I would like you to plug in your solution in for both equations and show that your answer makes both equations true. Okay, go ahead and pause the video and do that right now. When you're ready to continue, hit play and we'll go through it together. All right, so the answer, the solution, is this point. That is the point 2, nope, let's try it again. 3, 2. That is our x value and that is our y value. When I plug those numbers into the equations below, -2 times 3, which is my x value, plus my y value equals -4. That is -6 plus 2 is -4. That math does indeed check out. My other equation, 3 plus 2 equals 5. Yeah, 3 plus 2 is 5. That math checks out. So this has now been proven that that is our solution. Okay, so the solution to a system of equations is where your lines intersect. Little word problem. Says Jasmine goes to the store and buys $30 worth of Skittles and chocolate bars. This chocolate bars are $2 a bar and the Skittles are $3 a bag. If she bought 5 more chocolate bars than bags of Skittles, how many of each did she buy? Now, setting up a system of equations, I mean, if I just gave you this word problem and said, okay, set up your own system of equations and graph it or solve it, that's very hard. One of the hardest skills with system of equations is setting them up. So for this first lesson, I've done a lot of hand-holding, so to speak, like setting up and giving you lots of hints and stuff. So the first equation is all talking about money. Okay, so what was the total amount of money? Well, $30. How much money did she spend for chocolate? Well, it doesn't say. It says the chocolate bars are $2 a bar, but it doesn't say how much money she spent for chocolate. It just says she spent $2 on every bar. So we can actually put something like that. So she spent $2 times by the number of bars of chocolate. I'm going to say X is my chocolate. That way we understand when I have X in my equation, you know what we're talking about. And then she spent money for Skittles. Well, how much money did she spend for Skittles? The Skittles are $3 a bag. We don't know the total amount of money, but we know she spent $3 times by however many bags of Skittles. Y equals my Skittles. This is actually one of our equations. Let's keep going. Our second equation, we're talking about the candy. It says there's 5 more chocolate, or she bought 5 more chocolate bars than Skittles. So, see, how many Skittles did she buy? We don't know. That was our Y variable. Remember, it's 3 times by the number of Skittles. So she bought Y Skittles. Plus 5. How many chocolates did she buy? X chocolates. So these right here, these would be the equations you would come up with for that system of equations, from that word problem. And if you're looking at that going, holy cow, that is confusing. You're right, it is. And anytime you're going to have to do this, I'm always going to have these kind of guiding, these are called verbal models. I'm going to have these there for you to help structure the problem for you until we get more practice. There later on in one of the later lessons, it's all about word problems. So don't worry about if you're kind of confused now. This will become much more familiar when we get some practice. Okay, but I wanted to show you how this word problem could still be solved. So here, these are those same 2 equations we came up with. There's the y plus 5 equals x. There's the 30 equals 2x plus 3y. Those are the exact same equations from here. Okay. All I've done now is I've taken them and I've graphed them. So we can actually see, based off this graph, we can see how many did she buy of each. So my solution to this system of equations is this point right here. It's where the lines intersect. That is the point 9 comma 1 2 3 4 9 comma 4. But I think we need to do a little bit more, because just saying 9 comma 4, that doesn't tell me how many of each she bought. Did she buy 9 Skittles or 9 chocolates? 4 Skittles or 4 chocolates? I don't know. But I know that the 9 is my X variable, and the Y is, or the 4 is my Y variable, my Y answer. Do we know which one the X is? Is X the number of chocolates or the number of Skittles? We do know that. Right here. We labeled it. X was our chocolate. $2 per chocolate. Number of chocolates was X. X was our chocolates everywhere in the problem. So now we can come through and say, oh yeah, she bought 9 chocolates and 4 Skittles. That is now an answer that makes sense in this word problem. Okay? Having your variables labeled, which one is the X variable and which one is the Y variable, is, when we come to word problems, is very important. But I wanted to show you how even a word problem can be solved using this graphing method. What is significant about the intersection point of both lines? What's kind of special about that point right there? Do you know? We've mentioned it once or twice. It is the only point on the whole graph that works in both equations. If I would plug in 9 for x and 4 for y into both of these equations, it is the only one point that will make both of these equations true, because it is the only point that is on both lines on the whole graph. That's what's important about them. Now, The next step of this process is graphing. Instead of us being given a graph and then finding the solution, we need to go the extra step. Now we are going to graph it and find the solution. Okay, so now this is where we're going to have to dig back into our background knowledge on slopes and intercepts and graphing and that kind of stuff. You're going to see in almost all of these equations I have here, one of the equations is easier. This is already slope-intercept form. One of the equations is harder. This is not slope-intercept form. So this equation here, the bottom one, I'm going to do in blue, and I'll get my highlighter. So this is going to be my blue line. I can graph right away. I know that my slope is 1/2, and I know my y-intercept is -4. So my y-intercept is 0, -1, -2, -3 is -4 right there. And I know my slope is 1/2, meaning I'm going to go up 1/2. That is my rise over run. Up 1/2. Dot and repeat. Dot and repeat. And repeat. And repeat. Line. That is the blue line. That was my y-intercept of -4. That was my slope of up 1/2, rise over run. There's my line. All right, so now let's change color. Here is going to be my red line. Now, in order to graph this, there's a problem. That is not currently slope-intercept form. We need to make the y variable by itself, so we can do that. We're going to add x to cancel out the -x. Add x and y equals, I can't combine these together, but this is my x piece and this is my piece without an x. X minus 7. I'm bringing both pieces down. All right, so now this is my slope and this is my y-intercept. In case you don't remember what that slope is, that is the slope of 1, or as a fraction, 1/1. So now my line has a y-intercept of -7, 0, -1, -2, 3, 4, 5, 6, 7 is right there. And my slope is 1. That's 1/1, rise over run. I'm going to go up 1/1, dot. And repeat, up 1/1, up 1/1, up 1/1, hey, up 1/1, up 1/1, and in reverse. So my line extends the whole way across the graph, and look at that. We have ourselves a solution. We can see exactly where they overlap, exactly where they intersect each other. The solution to this system of equations is the point. 1, 2, 3, 4, 5, 6 in the x direction and -1 in the y direction. That is the solution to this system of equations. 6, -1. So by graphing both lines, I can find the intersection. I can find the one point where they meet. That is the solution. Okay? Hopefully this is bringing back some fond memories of when we did this previously. And if not, maybe you want to go back, and if you don't remember what we're doing, maybe you want to go back and watch some old videos on graphing lines. Let her be here. I'm going to do this one because it's in slope-intercept form already. So this is the easy one here. And then I'll go back and do the harder one. So my line has a y-intercept of -1. I'm labeling less stuff. I'm explaining less because we should know it. That's my y-intercept. I'm going to move the way the slope tells me to move, which is up 2/3. That is a positive 2/3. Rise over run. Rise over run. And in reverse, down 2/3 the wrong way. And now I've got a line that goes the whole way across my graph. Up 2/3, up 2/3, up 2/3, crossing the y-axis at -1. All right, my blue line needs to be solved for y. It is not currently y equals. So let's fix that. I'm going to subtract x on both sides. I have negative 3y equals negative x plus 6. That cancels out this positive x by using a minus x. So now he's gone. I have this. To get the y by itself, since this is a multiply by negative 3, I'm going to divide both sides by negative 3. And we have y equals 1/3, that is negative 1 divided by negative 3 is just the fraction 1/3. Remember, we like our slopes as fractions. 1/3 x, ooh, that was a little ugly, minus 2. That is this 6 divided by negative 3 is negative 2. So this is solving for y. Now this equation is in slope-intercept form. I'll re-highlight them. That's the equation I'm going to graph. So my blue line is going to cross the y-axis at negative 2. Dot. My blue line has a slope of up 1/3. So up 1/3, up 1/3. And you might be realizing there might be a little bit of a problem here. And go, wait a second, my lines don't intersect. Well, yes, they do. They just don't intersect over here. If you continue your line and extend it in both directions, you're going to see they're actually going to crisscross at this point right here. Down 1/3 the wrong way means they do crisscross right there. So my solution to this problem is the point -3, -3. That is the one point that is on both lines. It is the one point that will make both of these equations true. It is the only point that will make both of them true. All right, so 2 for me, 1 for you. Go ahead and pause the video and graph both of these lines right now, find their intersection point and the solution. When you're ready to continue, hit play and we'll go through it together. Alrighty, blue line. My blue line crosses the y-axis at +4. That is 0, 1, 2, 3, 4 is right there. My line has a slope of 1/2. That is rise over run. Run is always to the right. So up 1/2, dot, and repeat. And I'm out of space this way, so now I'm going to extend this way. I'm going to do the reverse. Down 1/2 the wrong way. And repeat, and line. So there was my blue line. Let's go with pink this time, this magenta color. Okay, so here's my magenta line. But that equation is not slope-intercept form. My y variable is not by himself. We can do that very easily by subtracting 2x on both sides. And we have y equals -2x plus 4. That is slope-intercept form now, so that's what I'm going to graph. So my line is going to cross the y-axis at +4. Hey, it's going to go down 2/1. Down 2/1. Your rise is a negative. You're going down. So down 2/1, down 2/1. See? Down 2/1, down 2/1. And in reverse, I'm going to go this way. So up 2/1 the wrong way, up 2/1 the wrong way, and now line. And I have a solution. In fact, I knew the solution before I even graphed this whole line, because the point here was the intersection point. It was on the y-axis. It is the point 0, 4. That is the solution to this system of equations. It is the one point that is on both lines at the same time. Last of these types of problems, I believe. It says here, we're going to graph an equation. So, excuse me, this is very much like the other problem, except now I'm not going to have the equations graphed for you. I'm still going to help you set up the equations because that's very hard right now. But then you're going to graph them on your own and solve the system of equations. Okay, so let's see here. It says a football team managed to score 24 points using only safeties, which are worth 2 points each in case you're not a football person, and field goals, which are worth 3 points each. The team scored 10 times that game. How many of each type of score did the football team get? Write a system of equations to model the scenario given. So, let's start by defining our variables. Let's say the x variable is the number of safeties. That was one of the things we had to find. How many of each type of score did they get? How many safeties and how many field goals? So I'm just saying let's make the first one the x's and the second one the y's. Y is the number of field goals. And this magenta is not great for doing long problems. So I'm going to change to red. I can change all this junk. Style red. That's better. That's better for my eyes. All right, so now, once we've defined our variables, this actually becomes quite simple. Check this out. How many safeties did they get? Well, they got X safeties. Right? Number of safeties, X. Plus, how many field goals did they get? Well, they got Y field goals. Equals 10. This equation is the number of scores. So if you add up the number of times they got safeties and the number of times they got field goals, we know they scored 10 total times. So scores plus scores equal scores. Our second equation is all about the points. How many points did they get for all their safeties? Well, they got 2 points for each safety. That's 2 times by the number of safeties. Plus 3 points for each field goal. It's 3 times each field goal they got. Equals the total points. How many total points did they get? I don't know. They scored a total of 24 points. So now we have our two equations. We have x plus y equals 10 and 2x plus 3y equals 24. We're going to take those two equations and I'm going to have you graph them and find the solution. So here's your two equations. These are the same two equations we just came up with. I would like you to take those equations right now, and I would like you to graph them in the space provided or on graph paper. I would like you to find the solution to the system of equations and then explain what it means. Like, tell me how many field goals did they get and how many safeties did they get. Go ahead and pause the video and do that now. When you're ready to continue, hit play and we'll go through it together. All right, now, for me to graph these equations, I have to take both of them and solve for y. This first one is very easy though, so all I'm going to do is I'm going to subtract x on both sides because that gets the y by itself. So now we have y equals negative x plus 10. I can graph that equation, but I'm going to go ahead, I'm going to solve this other one for y while I'm here. To solve this for y, I'm going to subtract 2x to cancel out that positive 2x. 3y equals negative 2x plus 24. I can't combine them, so I just bring both pieces down. Here's my 2x. Here's my 24. To solve for y, I'm going to divide by 3 on both sides, and y equals negative 2/3 x plus 8. Negative 2/3 x plus 8. So now I have both of my equations. Let me make that circle a little better. There we go. So now we're going to graph them. So I'm just going to go ahead, I'm going to scale. I think I'm just going to count by ones everywhere. So 0, 1, 2, 4, 6, 8, 10, 0, 2, 4, 6, 8, 10. My x's was my number of, not field goals. My x was number of safeties. And my y's was the number of field goals. Okay, so I'm ready to graph. So my first equation here, I'm going to highlight him in, I'm not going to use magenta, I'm going to use blue. So this is going to be my blue equation. My blue equation has a y-intercept of 10. Boom, up there. And the slope is -1. That is -1 over 1, which means our rise is down 1 over 1. Down 1 over 1. Down 1 over 1. Ba-boom, ba-boom, ba-boom. And it will continue right down this diagonal. My line's a little off. I can fix it. Technology is wonderful. There we go. So there's my blue line. Okay, let's do our orange line. Why not? We haven't done an orange line yet. So this will be our orange line. My y-intercept is +8. +8, +8. My slope is down 2 over 3. That is a slope of -2/3. Down 2 over 3. Down 2 over 3. Right there. And I repeat, down 2 over 3. Hey, we got ourselves a solution right there. But I'm going to keep going. Down 2 over 3 and line. And again, my line is a little high. I can bump him down just a teensy bit. There we go. So these lines are intersecting at this point right here, and that is the point 6, 4. That is the solution when they scored 6 safeties and 4 field goals. It's only that one combination of safeties and field goals that would give them both the 24 points and also the 10 total scores. So 6 safeties, because that's our x variable. This is the x's. 6 safeties and 4 field goals. Summary. If you have to graph 2 linear systems, how do you find the solution to the system of equations? When you solve by graphing, how do you find out what the answer is? Pause the video, think about it for a second if you need to. Well, the solution is where the 2 lines intersect. It's where they meet. It's where they cross. It's the one point that makes both equations true at the same time. It's the one point that's on both lines at the same time. Okay, so this has been the lesson on solving systems of equations by graphing. Thank you so much for watching. Until next time, toodles.